get out January 2019 for me?
Is it January or August?
August. Sorry, you're good. Yeah, you got me there. August. Thank you. August 2019. Yes. Thank you, Ryan. Everyone got nervous. August 2019. Did I tell you January?
Yeah.
I did.
That's okay.
You want to go print it out?
No, I'll just do it.
Go ahead. Go.
No,
I'll wait. We'll wait. It's my fault. So
you're sure?
it's my fault, Jerry. So. And I told you same thing, Sydney.
No, I have all of
Okay. That's because you know what you're doing. You're not here. Okay. Hurry up. Go ahead. We'll just talk about you when you're gone.
Okay.
I have I have like when I type in, it just always comes up as a fast name.
It's a 3-day week.
So, I mean, it doesn't really affect anything.
Yeah. No,
Try it again.
the post was, and I'm just like, I'm trying.
Thank you.
Yeah. I don't want
You
to.
I wrote,
I just have to.
but like, do you have the exact, questions that we assigned for homework?
Every day.
Yeah.
Yeah.
Because I'm like, well, just so I can look at it. Right, because I'll be like on the business of what you signed.
Or if we did it in class.
Okay.
So starting from last week. There are.
Well, like, yeah.
Well, that was day one. So on this column here, that's what we did in class, and this is what we did for I assigned homework on every day. So Tuesday, Wednesday, Thursday, Friday. And then one exams that we did.
For those notes, what parts of that do you need to see?
It depends on the day.
Okay. For
Depends on
days
the day.
2 and 3.
2 and 3, August 2022. Probably 1 through 9 we got through that day.
Yeah.
1 through 8, 1 through 9. I don't remember what we got on the video.
I got
Yeah. So that was the first day. What day? No, sorry, that was the first day, Nick. So you were here for that day.
Yeah.
Sorry, day 2, same exam. 16, 21, 25, 27. Can I start class?
Yes, you can.
16.
Yep.
And then day 3, I think I did too.
Day 3 was August 2022, 37 in that exam. So the last one, the big part 4 question. So we got to graph it though. Okay, that's a big part too. Okay, so figure out how to graph that. All right, because that's huge. All right. All right, we ready now? Jared's back. We're good. All right, here we go. 5 questions. The first question is new review. All right, new review, meaning we haven't reviewed it yet, but we did do it this year. So that would be, nope, let's keep going. There we go. Number 5, everyone. Number 5, August 2019. August, right? All righty. It's been a while. So let's review. We haven't done much of sine and cosine yet, other than graphing them. Cosine's -3/4. We're in quad 3. What's the value of sine now? I know cosine. I know the quadrant. How can I find the sine value? All right, same thing I asked last period's class. Anything you know about sine and what it's equal to? Nick?
Y value.
Y value, good. The Y value. It's equal to the Y value if I'm on the unit circle and I'm doing a problem involving the unit circle. It's the Y value on there. I don't have any unit circle here though. But yes, it is equal to Y. That's 100% true. It's equal to Y, but I don't have a unit circle to work on. So I need to go to the second thing it's equal to. Think you got it, Aaron?
Oh, no, I was
to say something else.
Okay.
All values in quadrant 3 are negative.
We could start there. I was going to get there eventually, but yeah, Aaron's like, I'm eliminating 2 answers right now. Why is he eliminating 2 answers? All students take classes. What's the only thing positive in quadrant 3? What's the T stand for? Tangent. And we're looking for sine, so I know sine's got to be negative. So no way it's going to be positive. So at least we give ourselves a 50-50 shot. Good. Good job, Aaron. Now my next question, go back to my original question. What else is sine equal to? Ooh, nobody in the other class remember this. So
Opposite over hypotenuse.
were you going to say that, Norm?
Yeah.
Good job. Yep. Opposite over hypotenuse. Remember that, SOHCAHTOA? Yep. Whoa, whoa. Nick gave me the y value, and I told him, well, I got to have a unit circle to take off the y value. I can only use opposite over hypotenuse if I have a what, though? Right triangle. I don't have one, but you can build one. In what quadrant? What quadrant are we in? 3. So go to quadrant 3. How do I make a right triangle in quadrant 3? Or does anybody remember the little trick? Oh, Jared, go.
Oh, you want to draw both?
Draw a little bow tie between the 4 quadrants, and everyone see quadrant 3. That's what your triangle should look like. All right, I got to put some numbers on this triangle. What numbers should I put on? Let's go back to getting cosine is negative 3 over 4. What's cosine equal to? Sine's opposite over hypotenuse, cosine?
So it's
Adjacent over hypotenuse. So what am I going to put on my adjacent side here?
3,
Negative 3. And how about my hypotenuse?
4.
4? Adjacent over hypotenuse. How do you find the missing side?
What? Opposite plus negative 3 minus 3 squared.
What do you do? What's that called?
4. Theta.
Pythagorean theorem.
Pythagorean theorem.
Pythagorean theorem, everyone. That's how we're finding the missing side. A squared plus B squared equals C squared. Where's the 4 going in Pythagorean theorem? C. Hypotenuse is always C. And then negative 3. Make sure you put it in parentheses if you're using your calculator. And now we're solving for B. I'll give you guys a second or two. Go ahead. What's your B value here?
Square root of
Should be square root of 7. If anybody's getting 5 out, because you got the square root of 25, you got to put the negative 3 in parentheses in your calculator. Can't leave it naked. Put it in parentheses. All right, so this is radical 7, right? But hey, take a look. See where it is? See where it is right now? Here? What do you know about these values on the y-axis?
Negative.
Yeah. So I got to put a negative radical 7. Or remember that sine's negative in the third quadrant. All right, what's opposite? Actually, you know what? I got to start. Let's pick off some people here. 10. What's opposite?
Negative 7. Negative 7.
Radical 7 over hypotenuse.
4.
There we go. Yep. Whew. So y value and opposite over hypotenuse. Questions? All right, go to 15. All right, now you're going to start telling me how to do these problems. Time to teach me a little something here. Today I'm just looking at reactions here. How are we going to approach these problems now? So what's the solution set here? What's our approach? What's your approach going to be? Jared?
I would plug in.
The answers are somewhere there, right? So plug it. What do you mean plug in now? So you're going to take what first?
I would take 0 and
Yep.
plug it in for x.
0 stored in for x, everyone, and see if the left matches the right. If it does, it's a solution. So I store in 0. Does the left match the right? What are you getting right away
No,
when you type in the left side?
it is.
What's the left side giving you?
Error.
Hopefully everyone getting an error when you store in 0 and type in the left side. You're getting an error?
Yeah.
All right, that don't even bother testing the right side. All right, error equals error doesn't mean a solution. Error means it's gone. It's not a solution. So 0 is not a solution. So that eliminates choice 1 and eliminates choice 2. All right, let's go to choice 3 now. Is 2 a solution?
No.
2 also gives me an error, correct? So it is not. Anybody know why it's giving you an error? Jake?
2 squared minus 2x equals 0.
Can you have 0 in the denominator?
No,
No, and that's what's happening when you plug in 2 and 0.
it's undefined.
Correct,
So
Tim.
it's
Undefined.
not a choice.
So we talked about this yesterday. What's number 4 mean?
Nothing.
No solution. Empty. So no solution. I'm not done with this problem though. All right, I wouldn't be doing my job if I didn't say, what if this is a part 2? And there's no plugging in or storing option. You got to actually show work here. So how do I get to no solution just showing work? Here we go. Fractions. I need a common denominator. I'm going to need to start with a common denominator. Before you try to figure out what the common denominator is, can everyone look at all 3 of the denominators and tell me something about one of them? No?
They all have those.
Okay, they all have x. Let me help you a little. You can go further on one of them. What do I mean by that?
The greatest common factor is
X squared minus 2x. If any denominators can be factored, you factor them before you find the common denominator. So what can you take out of the first one here? An x, and what's left? X minus 2, good. Now you look for a common denominator. Common denominator. Common. What's in common between all 3? An x, and because they have x's in common. And what else do they have in common?
-2.
They're together here with the x. So they have these x's in common and an x minus 2 in common. So there's your common denominator, the x and x minus 2. So factor everything you can, then write what's in common. You guys remember, what do I do now with the common denominator once I find it? I'm going to just clear, I'm just going to clear all this out.
What do you like?
I take each fraction and multiply it by the
Need to.
common denominator. So let's take that first fraction, multiply it by its common denominator. And you look to what cancels out. What can I cross out in the top and the bottom on this first one? 4, what can I cross out on the top and bottom? Everything. Does everyone see everything's gone? And what are you just left with, Reagan? 10. I don't want a denominator left. That's my goal when I solve these. I don't want a denominator left. Plus, go ahead, multiply this one by x and x minus 2. What's going to cancel here? 14. X. What are you left with? And 4. So I got to multiply them, right? Distribute. 4x minus 8. No denominators left. That's my goal. I don't want any denominators left. And then finally, last one, x and x minus 2. What cancels out here? 6. X minus 2. What are you left with? 5x on this side. Go ahead, guys, solve it. There's nothing fancy there. Whoa. Well, wait, what? Is everyone getting an actual answer here?
No.
I am.
So,
Getting 2? 2?
yes.
But didn't we just store everything in and we said it was the no solution?
Yes.
How am I getting 2 then? I haven't done what? Check it, darn it. Radicals, fractions. Anytime you solve for a variable that has a radical or a fraction in it, you got to check. And what just happened here when we checked 2? What came up on our calculator? An error. Sorry, that's a reject. That's how you get no solution now. All right, you have to check anything that involves a radical equation or a fraction. Jake,
And I had to make the other side equal to 0 before like you did any of the
do I have a squared here?
oh no.
No. All right, I don't need to factor here. The only time you need to make it equal to 0 is if you're about to factor. And I'm not about to factor. Okay? I don't reject. Reject. There you go. Good? Yep, you're still hungry. You're not full yet, by far. 17. I want to see what you do here. I want to see everyone's reaction to 17 other than crying. I like the reaction so far. All right, good. Oh, whoa. We've seen this before, haven't we? We've seen this type of problem. What are the 2 words up here that signal that you guys are, all you guys that are going to your formula sheet? That's not on the Regents. Compounded. Yep. Compounded monthly in this case. That's what triggers me off here. Compounded monthly. If it was continuously, I'd use APERT. Monthly, I use the one on the formula sheet, which we're going to be very familiar with in 2 weeks. P plus, times, sorry, not plus. 1 plus R over N to the NT.
What is the difference between N and T?
N is the number of times you compound it.
Yeah.
T is usually the amount of time that you're keeping your money in there.
So what I do?
Whoa, we're going to ask somebody in a second what we're going to do. Okay, but that's the difference. So number of times I compound it every year, basically T is the number of years I'm doing it. Okay? All right, who's up here? Going to need somebody. Who's got 4? 4? All right, you got this. Let's go. Same person, same number, called on, same exact question. Almost got it. Almost got it. I reamed him out too because he was better than that. You ready? Are you better than that? Principal. What you start out with. Good. Relax. You're making me nervous now.
Making me nervous.
Making me nervous.
Pressure.
Oh boy, there is pressure. I want to put it on you here. Good call.
0.035.
Point what? Sorry.
0.035.
Good. My rate as a decimal, divide by 100. This is where we went off the rails last period. He said the same thing. Same thing. Compounded monthly. 12 times. All right? Monthly. 12, everyone. Quarterly, I throw a 4 down there. Semi-annually, hardly ever see that. I throw a 2. Annually, I throw a 1 down there. All right, let's keep going. We already know N is 12. And how many years am I doing this for?
6.
6 years. There you go. And now I just have fun on the calculator. Compounded monthly. Compounded continuously, that's when I use P times ER to the T. What's up?
Why would T not be 72?
That's what I thought.
This is okay, you're doing it 12 times. You're doing it 12 times a year for 6 years.
Oh, yeah.
Okay? The T is just the amount of time, not the number of times you're compounding. T is the time that the money is in there. Okay? T is time, not the number of times it gets compounded. Okay? And hopefully you guys are good on the calculator. And we've got what? Choice 4? Choice 4, all good? All right, let's go then. Everyone's good. Let's see what you do for 20. Let's see your reaction to 20. Okay, good. Okay. Okay. Okay, good. All right. Let you read through it. I just want to know how many solutions there are when they're equal. Hey, I don't know if some of you guys are trying to set these equal, and I don't know how you're solving that if you're setting it equal. Good luck. Maybe you could teach me, because I have no idea if I set those equal how to solve it. But I do know where to go to figure out how many solutions there's going to be, or even what they are. I'm waiting for more people to pick it up. This can all be done on the calculator, right? Where's if I graph 2 graphs, where's the solution going to be? Where are the solutions on a graph? Intersection points, right? And I don't care what the solutions are. I just want to know how many there are. So yeah, I'm going to my graphing calculator, y equals, typing it in. Remember, ln is on the left side here. E is right above the division sign. You graph it, and I don't know what settings your window is in. I have no idea, because we've done a couple different problems. If you want it, somebody teach me. I was out that day. How do I put my calculator back to the original window settings? Anybody remember? If mine's all crazy right now. Little help? Anybody, Jake?
You go to zoom and then press 6.
There you go. Zoom standard will get you back to the original. Now, somebody asked a great question last period. My calculator doesn't look as clear as yours does up on the board. How can I see a little bit if it zoomed in a little bit? Because I don't know, maybe your guys are experiencing the same thing. It's not as clear as how many solutions is it up on mine. Make your window, go ahead, Aaron.
Oh, just like zoom too.
Yep, you can make your window a little smaller if you want. Okay, remember it's 10 by 10 now. Maybe you want to make it -3 to 3. So take a look. Hey, I make mine a little smaller. I go to window. Maybe I want it -3 to 3 on the -3 to 3 on the X, and -3 to 3 on the Y. Watch how much closer this bad boy gets now. I think it's now much clearer. All right. So if you need to see a little less, you know how to change your window settings. So we now know it's definitely 2 solutions. All good? Questions, comments, concerns? I got one more for you. What's the issue? Should be 2 solutions.
How do you know about that?
How many times do they cross each other? right? That's always where two equations are equal, where their graphs intersect. And they intersect in two spots. And one more here, part 2, 29. Be prepared. I'm going to get fired up here in a minute. Not like that's a shocker. Is x plus 2 a factor of any of those two? All right, I get it. Some of you see, oh, factor. I love doing grouping. Just stop. It's not the way to go here. We went over this yesterday. How do I figure out if a term is a factor or not? What do I actually have to do? If it's a factor or not, divide it into it, and hope that there's a remainder of what? 0. If there's a remainder of 0, it's a factor. So I'm going to do synthetic division twice. Once on each polynomial here. All right, let's do it on P of x. What goes in my corner box? What do we got here? 13. What goes up in the corner there? Negative 2. The opposite of whatever I'm dividing into. You want to take the numbers across, Jared? Or you want me to call on somebody else?
It. Yeah.
Go ahead.
All right, so 1, -3, -16.
Got him.
What?
Got him.
What
Got
is
him. I thought you were so confident. I was like, he knows the trap. And I'm going to be so disappointed that he knows it.
-16?
No.
That's not it?
No. Ready? I know.
Aaron.
Who?
Aaron.
No. 4. Look at the exponents. 4, 3, and then it jumps to what? 1. I don't have a squared, but I need to fill it in with a 0. Love this problem.
All right.
Now you can keep going, Jared.
0, -16.
And
then -12.
there you go. Everyone good while we're plugging in a 0. All the exponents have to be represented.
I know.
Were you guys going to say that?
I was going to say
Yeah.
0.
Oh, were you?
Yeah.
Were you? Okay.
I'm a young buck.
Yeah. First step,
Bring the 1
15.
Down.
Bring the 1 down. I will fully admit my mistakes. I did this answer key last night, and I just flew past this, and I made a mistake. So take your time. All right, it is because you're going to be multiplying, adding, and it is very easy to make a mistake. Now you multiply 1 times -2, you get -2, and I wrote -6 underneath because I'm going too fast. All right, one job, right? One job. Act like you can teach this course. -5, 10, and then 10 again on the bottom. And then what do I have? -20. -30. So these numbers are getting out of control. And then what's here? -36 times -2 is what? 72? Whew. Remainder. Huh. 60. Make sure you get 60 at the end. So is x plus 2 a factor for P of x? Nope, because I have a remainder. I have a remainder there. All right, let's try it for Q of x now. Anybody want to give me the numbers across here? This is not as fun. 13.
All right.
There's no trap. Let's
yeah,
go.
There isn't any. Trap.
There isn't.
1. Oh, first of all, you start with the -2 in the box. 1 -3.
You're just trying to
negative
make up for the last one. I can see right through you. Drop the 1. -2. -5. What do I get there? 10. -6. And 12. Oh, what do we got? We got a winner.
0.
We don't have a remainder. So that means, so we got to write a little statement here, right? X plus 2 is a factor of, which one was it? Q of X? And what's your because here? How did we know?
It doesn't have a remainder.
There was no remainder. That's how I know it's a factor or not. It goes in, divides in evenly. No remainder if it's a factor. All right. I'm going to give you 8 problems to do, and I know that's more than usual. That's because we're not talking about them until Friday. I'm not talking any Algebra 2 review tomorrow. You got your quiz. So these are actually due 2 days from now, so that's why it's a couple problems extra. Same exam that we've been working in, August 2019. These 8 problems for me, and you can go on them right now. 1, 4, what do I got? 6, 7, 9, 10, 14, 19. All right, those are the 8 we're going to talk about on Friday, whether you're ready or not. And I only assign problems that I know you got a shot at, okay, that you should have a good success rate with.